Okay, here we will cover about recurrent relationship. Recurrent relationship is related with continuous of series. Okay, so we have a first order linear recurrent relationship with constants of coefficient. For example, we have relationship of x n plus 1 equal ax plus bn when n equals 0, 1, 2, 3. So we can see that where a is constant and bn is known as sequence. So this one can be simplified if bn is equal to 0, means that xn plus 1 is equal to xn. Okay, or in other general form is xn plus 1 is equal to axn plus b. Okay, so means the recurrence only affected on the first n. We can see that as a summary. Okay, the first order occurrence is we have a general solution for first order recurrence relation, which is xn plus 1 equal axn plus b. So it can be summed as general solution, which reduce xn plus 1 equal axn. Okay, means that if you notice here, for the first order recurrence, okay, we call it first order recurrence. Okay, so for example, we have xn plus 1 is equal to axn plus b. Okay, so this one can be simplified into a general form of xn plus 1 equal axn only, means that every n equal to 0, 1, 2 or 3 and the rest is only affected on axn. So b doesn't affects. So this one we call it first order occurrence. Okay, for example, we have another one is second order occurrence. Okay, second order linear occurrence with constant coefficient. Okay, this one is the rest is affected. Okay, if you can see here, en 3x, the first one has a first order occurrence, then the second one also affected, then the third one also affected, so we call it as a second order occurrence. For example, we have here, okay, for second order occurrence, okay, so you can see here, for example, you have en equal to 3x n plus 2 plus 5x n plus 1 n plus 1 minus 2xn. So if you can see here, if your x n equal to 3n, so we can put everything as in xn. So you can see you will get en equal to 3. Okay, change the xn into 3n, you can 3 times 3n plus 2. Okay, this one here, plus the second also affected with 5x times your x is 3n. Okay, your x is 3n. Okay, your x is 3 and so plus 1 minus 2 times 3n. So here you can simplify, we know it here, so become 3 times 3n times 3 power of 2 plus 5 times 3n times 3 power of 1 minus 2 times 3n. So from here you can see you will get this value. So the second order occurrence means that it's not affected on the first order only, it's also affected on the rest of occurrence. So the first one is only affected on AXN, so B is not, there is no BN, but the second order occurrence is affected on the first one, the third, second, and the rest. Okay, you can see here, you just change 3 negative n, just put it here, automatically you will get the answer. So means, in summary, is the first order and second order recurrence is affected by the rest. For example, this one is summary of second order recurrence. You can see the first one affected, the second one affected, the third one also affected. Means if Cn is equal to, for all n is 0, so we call it as a homogeneous. So this one affected and affected. Okay, next is all about limit and sequence. Okay, in this section we are talking about each of the property sequence should have a limit, or we call it is a converged sequence. What is converged sequence? For example, you have x, when x equals 0 you have 1, when x equal 1, x1 you have 1.8, x2 is 1.6, then x3 is 1.64, means that the values start to be increased and fluctuate. If we keep on calculating this one, we will notice that, for example, there is one moment x22 you will get 1.41. When you calculate x23 you also will get 1.41. So for example, you keep on calculating x24, x25, the value is 1.41, means that in this sequence it start to be converged, or x and xn we can say equal to 1.4 for n is higher or greater than 22, means that the value start to be converged. So as shows the here is, for example, the terms x22, x22 of the sequence are indistinguishable to 2 decimal places, so the difference is less than rounding error, means the difference between the x, this one and this one is a very small error. So we can say this one is started to be a conversion, converge. Okay, this is the term. So for example, this is a properties of convergent sequence. So every convergent sequence is bounded. Okay, that is, if we have an from 0 to infinity is converged, then there is a positive number of m, such as modulus for an is less than m. So the main concept is, if you have two main equation of series for an, for example, has a limit of a, okay, we know there's a conversion limit of a, then bn also have limit of b. If an plus bn means the limit also a plus b. So if an minus bn, the limit is a minus b. If a times bm, the limit is ab, and a divided by bn, the limit is ab, with the b and should not be n and b should not be 0, if not it's undefined. So you can see here, for example, we have xn n divided by n plus 1. Okay, when we put it x equal to 0, 1, 2, 3, we will notice the sequence is from 0 become 1 over 2 half, become 2 over 3, become 3 over 2, means that it start to be reduced. From this value we can see that xn approximate to 1 means n approximate to infinity, so it start to be infinity. So this one we also can be written as xn equal 1 minus 1 over n plus 1, means that the 1 over n plus 1 is very small, which is insufficiently large. So if this one can be simplified, become xn equal 1 over 1 plus 1 over n. If 1 over n approximates 0, means your n is infinity. So automatically here we will get a graph of conversion, means the values start to be reduce and converge. Meanwhile, for the b1, if we simplify xn, okay, we simplify it divided by n square here, okay, you will get something around about this. When you change the n approximates towards the infinity, so you will find xn is 2 over 5. So the value start to be going up until one value will be converged. Okay. This one is about computational limit. This is we are talking about divergence. Okay, here is some example of divergence. Okay. Okay, this one is I think we have covered infinite series. For example, you have convergent infinite series. For example, you have this value from 1, 3, 5, 7, 9. So we know this is 2k plus 1. So this arithmetic series is can be written as summation of k equal to 0 n minus 1 or 2k plus 1. Okay, so which is equal to n square term. So this is clear that as n infinity, n is infinity, the series does not converge to a limit by its diverse series. Mean it keep on increasing, the value keep on increasing, so we know it is become divergent. Okay, for the second one also, as n x with n increase, then the value start to be increase and n become larger, so there's Sn, the value also keep on increasing to infinity, so we call it as a divergent. For example, this one, okay, for this value, okay, the geometrical series ratio is 1 over 2. So when using this formula, when n is keep on increasing, n towards infinity, means 1, 2, 3, 4 until infinity, the value start to be approximate to 0. So automatically our Sn is, we call it converge. Okay, start to be reduced. Okay, this one also, the value start to be converge. Okay, this is several tests of for conversion. So we have comparison tests. Okay, so we have for example, we have this one factorial, so we can do a comparison test, okay, for each one. So there is a D-Lambert ratio test. I think this is you can focus on D-Lambert ratio test. Okay, the concept is, suppose we have a serial positive, for example, so the limit of un plus 1 divided by un equal to 1 is exists. So if your L is below than 1, means your ratio equal 1, so we call it as a divergent. But if your ratio is bigger than 1, we call it as, if L below than 1, we call it converge, means keep on converge. But if your L is keep bigger than 1, means diverge, it become bigger. So it's reduced than 1 is become lesser, means we call it as conversion. So you can focus on Lambert ratio. For example, we can see it here. So you have 2k divided by k factorial. Then here we know that we use the formula of un plus 1 divided by un, means un plus 1 is 2n plus 1 divided by n plus divided n plus 1, okay, divided by un. So divided by, change to 2n divided by 2 factorial. So you will get 2n plus 1. So if n approximate to infinity, so automatically we get L is equal to 0. So this one is a converge because of here is below than 1. Okay, for example, the second one, you have un plus 1 divided by un. So here you have n plus 1 divided by n plus 2 square divided by un and un plus 1. So this one can be cancelled. Okay, then at the end you get 2. So when you get the 2, we know that here your 2 is L is bigger than 1, so it's a diversion. So this is how to find the conversion and diversion. So means that if un okay, this is the concept. Okay, this is another absolute conversion of series. Okay, so this is you need to remember this concept. Mean if your limit un, just now what I'm saying, un plus 1 divided by un, okay, is lesser than 1, so automatically we know that is a converge. If the limit of un plus 1 divided by n modulus is bigger than 1, means it's a diverge. If your un divided by n is n, then no conclusion is possible. So you need to remember this concept by referring to previous example. Okay, next is all about power series. Okay, power series is series will in general converge for certain value of x and diverge elsewhere. So by applying Amber ratio, just now is the ratio between convergence and diversion. Okay, we can say that, for example, the limit of is below than 1, thus the series is converged. Okay, but if your value is x is reduced than the value, so we call it as diverge. Okay, so for example, here we have from n until infinity x power of n divided by n. So when here is an 1 over n, so that, okay, based on here an 1 over n, so an divided by an plus 1 is n plus 1, okay, divided by n. So we get r equal to 1. So the domain is converged because of x is between 1 to -1. So the series diverge for x modulus bigger than 1, for x equal to 1, and x equal -1. Okay. So the most important thing, you need to know how to use the ratio of diversion and conversion. So use the ratio of the Amber, or you can use then you start to know how to determine the ratio. Okay, for example, this one, this is very important, diversion and conversion, how to determine diversion and, okay, the rest you can refer from other notes.